In this video, let's create random circles like you see on my Rhino screen. To begin with, let's create a new document. Let's place a grid on the screen. There are two different types of grids, rectangular grid and the square grid. Let's use the square grid for now. And you can see there's a very small grid right there. We can change the size of the grid by change the input value of the size. Let's use 20. And that's the size of the grid. Two other inputs, EX, EY, are the number of grid cells. Let's use 10 by 10. So I have a grid of 10 by 10. Now, if you look at the output of it, I have a total of 121 points and 100 cells. You can visualize all the points using the point data holder right there. You can visualize all of the points. Now we would like to create random circles using these points as the centers of the circles. So let's create a circle using the CNR and place the points as the center and give a number for the radius. Let's use 10. Then you'll see that I have 121 circles using the points as the center points. And if I reduce the size of it, you can see how this changes. And of course, I can change the x extent or y extent. So when I have a 20 by 20, the number of cells is 400. And number of points will be 441. That is 21 multiplied by 21. To create a random circles, we can use the random component and create a list of random numbers as the radii of the circles. Because I know that there are 441 values and we need 441 different random numbers, I can use 441 as the number of input for the count. So I have this value here. If I replace these values to the radius, because the value is too small, it is very difficult to see. So let's remap these values using the remap component, plug in the list, and that is the domain of the source. So we can use the bounds component to retrieve the domain of the original source. Use a new domain. I would like the size of circle to be between 2 to 10. Now I just effectively converted all of these values from 0 to 1 to 2 to 10. If I replace that, I created some random values. The problem is that you can see all of the numbers on the first line is the same. On the second row is the same and things like that. And on the last row, there are a lot of overlapping windows. The reason for that is the data structure for this output P is tree structure, but this is list structure. To create the true random sized circles is to flatten this tree to list structure. So I have a matching 441 input with a 441 radii. And this seems to be all we need, but there is still is a problem. The reason for that is if I change the number of EX or EY, you'll see that something's happening and the last point overlapping concentric circles. The reason is the number of this P, the points for the centers, is reducing to 357, but the output stays at 441. The fundamental cause is that there is a hard-coded value for the number of circles. This relates to the consistency of input data. So instead of using a hard-coded value, it is better to derive the number of values based on the same input here. So one way to solve this problem is to use an expression. So input that as x, that as y. So the total number of points would be x plus 1 multiplied by y plus 1. Now, this issue just being resolved. You can see that no matter what you do, you will always have a random sized circles matching. If this is not your thing, you don't like to deal with this math, another easier way or the easiest way is to retrieve the length of this list. So no matter how you change these two sliders, this value will always retrieve the length of this list and use that as the end input. Now you have the exactly same function with a little bit of different way of achieving it.